Hi everyone, it's Nono here, and I want to welcome you one more week to the live stream. Today we're going to continue with previous efforts on training Pixel2Style2Pixel. This is a machine learning network that has been open sourced, and there is a published paper in the open. And yeah, so today I'm not sure how long we're going to go for, at least 30 minutes or 1 hour. And I have my tablet here. We might do some doodling, some thinking there. And we're going to get started really fast. So there's not going to be a lot of introductory content today. All right. So for those of you who are new, this is a space that I, Nono Martinez Alonso, reserve every week to do things that have to do with digital art, creative coding, and machine intelligence. And also things about simple living, as I do on the Getting Simple podcast. You can listen to all of the previous episodes on Apple Podcasts, Spotify, or wherever you get your podcasts, or even visit gettingsimple.com and take a look. If you want to support the channel, you can click on the like button, and you can also subscribe and click on the bell to get notified when I go live next or upload new videos. And you can also join us on the community at Nono.MA's Discord. You have an invite, and also you can access through that QR code. I want to take a quick chance to say happy Thanksgiving to everyone who's in the US or celebrating Thanksgiving anywhere you might be in the world. I'm currently in Spain, so we don't celebrate that right now here, but I guess we'll celebrate later in the year. And yeah, so we'll record a quick intro as we do always, and we'll jump right in to catch up where we left it last week. Hi everyone, it's Nono here, and this is one more working session of the Intelligence and Sketching project. This is a collaborative AI platform that we're trying to create here, and when they're edited, you'll be able to see a lot of these sessions compiled in a single playlist. This is work that we do week after week, and you can see there's a progression to build a web app and also to learn how to train with custom dataset different machine learning models to create interesting generative models and other types of algorithms. Today specifically, we're going to continue with Pixel2Style2Pixel training. This is what's called the pSp framework. There is already 3 videos that we've covered on the topic. In last video, in part 3, we finally managed to get a training algorithm, so a notebook that trains Pixel2Style2Pixel with pre-existing data and models. But today we want to take a look at how we would go into customizing that data set in order to create a model that is more a model of our own, not a model that we're just training with other people's images. We've trained a StyleGAN previously in this live stream. I don't remember exactly the number of the episodes, but you can look at them at the YouTube channel. They're all in the playlist of Nono.MA Live. And yeah, so let's get coding. And feel free to tell us where you're connecting from, if you connect live, or leave a comment if you're watching this offline. All right, I said before, right? So I have here the tablet. So this is the Remarkable tablet. I've shown this before on the live stream, but today I'm hopefully gonna be using it as well, right? We could come here and hide this UI, and yeah, we have a drawing board here. So this would be Pixel to style to Pixel, and this is part 4. Right, let's get started, and I'll put here, this is live 51. All right, so I guess we can create a new page. We're gonna take a look at what we're gonna do today. So you know what this network is trying to do. usually you have a bunch of a bunch of images, right? So we'll say you have a ton of images to train StyleGAN. So these are your images, right? And we get these images into the machine learning model. And what StyleGAN does is something called unsupervised learning, which means that the model is learning from the features in these images in here without you telling it anything about them. It's just like analyzing them in the way that the model is being programmed to do. StyleGAN is a model that this is, we input images for training, and we actually get a model that we can use. In the case of the videos we've been doing, it's a .pt because that's using PyTorch. And we need a GPU and CUDA and some other plugins to run these algorithms. More recently, we've been using pSp, right? So let me make sure that I'm not covering that. All right, yeah, so we were using pSp. So pSp tries to, because so you understand a bit more what's going on here. If you have a StyleGAN model, you need to input a vector, right? You can have a Z, which has 112 components, or W plus, which is a bit different. And for each of those inputs that you put into the model, you're gonna get an image. And that image might contain a face if you train that with faces, or a landscape if you train with landscapes. And you could train it with anything you want. So for example, we could train it with sketches of chairs, right? And we would get chairs out of the model. And the thing is, it's really weird to know which input vector you have to give StyleGAN to get a specific image, right? So we have here the Z vector that we've seen as well in some previous videos. We input into StyleGAN, and then we get an image. And by modifying each of the components in that vector, we can get a different image. What happens here is that it's really hard manually to change those parameters to change different features of the model. What has been done is that there is a way in which we can, and I don't exactly know how that's called, but you might have a person smiling, and by changing certain features that only affect the mouth, you might be able to get different expressions on that person's mouth, right? Just by changing certain components of that, those input vectors, right? Other features might make their hair look different, or like different colors or different appearances, right? And that is something that it has been done at least with the Flickr Faces HQ dataset, which is a set of, I don't know if it's like 60,000 or more images that are on JPEG or PNG format, and that actually are on the size of 1024 by 1024. You train the model, you get a PT file, right? So we said before, it's a PT file that is PyTorch, and then you can get many of these images that I was showing before out of the model. All right, so here enters pSp, the Pixel2Style2Pixel model. What it does is it tries to learn a mapping from an input to an output, but in this case, not an image. So we get an input image, and it tells us the Z, or in this case, the W plus vector that we need to input into StyleGAN to get that specific image back again. This is something that is called StyleGAN inversion. So that inversion means that we're sort of reverse engineering the W plus vector from an input image to input that vector into StyleGAN and then get back the same image. Why would we want that? Because StyleGAN has a set of images, and whatever is on its insides, right, is what's called the latent space. And if something's not on the latent space, you're not going to get it out of StyleGAN, right? What happens is that you might have a lot of faces or of people or caricatures or landscapes, but we're trying to map or learn a mapping from input images from whatever domain we have into W plus vectors that relate a lot with the StyleGAN model. So this vector here and these input images don't have to do anything with the latent space. Well, the W plus vector does, because it informs what we get out of the latent space. But these images don't need to be exactly the same, or actually we don't want them to be the same as these ones. We want to have an image. So for example, we could have something like this to represent a tree. We want to find the W plus vector that when input into StyleGAN gives us maybe the photo of a tree with a lot of detail, because maybe that StyleGAN model has been trained with really detailed images of trees, maybe even with a landscape behind. So we might want to input sketch and then get out a photo, right? So how would this be done? So we'll need a lot of sketches and then their mappings to images, and then with this would be our data set, and we'll train a model that goes from basically the model would be this, right? So that's the pSp, what's called the pSp encoder. We'll encode the sketch into a W plus, and then we'll retrieve the photo. And basically we end up with something in which we can go, for instance, from a sketch to a photo, or the reverse. I mean, it doesn't really need to be one or the other. It could be many different things. So we could have this sketch, but then we could have like a fully fledged portrait of someone, right? With texture and with their shirt and many other things. All right, does that make sense? So this is what we want to achieve, right? So to do this would be our data set, but to train the data set will have to be slightly different. This would be, well, actually this could be our data set, right? Sketch to photo. But the idea later is that we actually go from this to a W plus vector, and then it's StyleGAN that gives us a photo like that one, but from the latent space, right? So this is basically like grabs image from latent space. All right, so let's see how we can actually do this. Cool, and let me take a look if there are any comments. I want to say hello to Rob. Thanks for connecting today. Also to Bea, that I see you're online, and also to Sujay Kumarji. Nice to see familiar faces around here. Okay, so I said let's get coding. This has been more diagramming, but I think that clarified a lot of the things that we need to do on my mind, and hopefully also in yours. let's try to retrieve now the training notebook that we had last week. And again, you can go to Nono.MA/live/50 for part 3 of Pixel2Style2Pixel training. So it would be 48, 49, and 50, and then this is 51. So from 48 to 51, so far we've gone through Pixel2Style2Pixel training. This was the 18th of November, and we're gonna make yet another copy of this notebook in order to continue but not override what we had in livestream 50. So save a copy in Drive. All right, so this is V3 and it's slide 51, and the date is 25th of November. All right. Okay. I'm gonna add here this. All right, so this would be also in here just to leave it on the notebook. All right. So I don't think we need to do a super detailed catch up of this. I think we all have seen more or less what this is about before. All right, so let me do a really quick run on this, right? So we do have, just go into a directory, we install, let's actually, because there are outputs here, we can see what's going on. So we have this, so we just import the system, go to content and specify that we want to clone into here. We install Ninja, which is a dependency that pSp needs. We clone so this repo to our Pixel2Style2Pixel directory. We enter that directory, we do some replacements. So from something that looks like this, we go to this and this. So we're saying where our dataset is going to be placed. And then we download two models. We download the IRSE50 model taken from Trevian, and the StyleGAN model config F trained on Flickr faces high quality, 1024 by 1024 as I said before. Define this helper, download a really tiny data set of 100 images from my Dropbox account, and we train. All right, so this was some code to see available, see and release available GPU. All right, so let me see where we were last week. I remember that we downloaded this folder. So this was one of the models. So it's 1.1 gigabytes, and this is a trained model that we saved in iteration 200 last week. As I said, it would have been super fast to copy this over to Google Drive instead of downloading it here. But this is what we have. And we could use this directly with the notebook that they provide here in order to do inference. Let me see, because I might have a notebook already for this. Okay, so Pixel2Style inference playground. All right, yeah, so I have this one here that I used before, and Okay. So yeah, this might be a bit convoluted, like maybe too many things. I'm gonna also clone it because we're gonna simplify it here. Save a copy in Drive. And this is gonna be also today. And we're gonna do inference. And this is gonna be B3 live 51. Okay. So what I'm gonna try to do is put this model into this notebook instance and run images through it. I guess we need input images. Yeah, we need input images. And that model is not trained for too many epochs. So I guess what we can do first is let's have a roadmap here. Let's see what things we want to do today. So I would like to do, and yeah, hello to Jean-Marc. Thanks for passing by, and it's nice to see you online. So we go to our desktop, we go to 51 MD, and what we want to do today is all right, so train Pixel2Style2Pixel. Download, or let's say copy train model to Google Drive. Download train model from Google Drive. And this is to inference notebook from training notebook. And here we want to predict with, yeah, just predict. And this is Pixel2Style2Pixel part 4 live 51. All right, so train with sample Flickr faces HQ dataset. All right, so how does that sound? I am going to go into here, so we're validating all the time, max step 5000. Okay, because this actually trains fast, I'm gonna leave it at 500, so we're going to test that this works. Now this is fun because we know that it's meant to work, so we just run all and clear all outputs, and this should work. So we're gonna see the model, the trained model being saved into one of the folders inside of here, so we can go to our file browser. And what are we gonna see first? So we'll see a model, and we actually already have a model here, but we need to copy this over to Google Drive. So what I'm gonna do, because I have a code base, probably we should build a document on GitHub or somewhere with all of the commands that we're learning here, because I have a style gun, predict and train notebooks, as we do with this, in which we do this of, like, you see here. So we're actually mounting the Google Drive to be able to simply copy things to Google Drive and from Google Drive. So we probably can just do this and copy it here. So we'll do that first thing. So we'll mount Google Drive. Yeah, I don't know. I mean, I'm not sure how much we need to. Actually, I mean, if we could save, yeah, I don't know where the order is. Better to have it, but okay. So let's actually put here install dependencies and clone Pixel2Style and clone repository. Yeah. All right. So it seems like we are in the training, which is good. So we're training here, and let's see if everything's working. We have that code here to mount to Google Drive, to copy, and so to copy to and copy from, we can just use like simple shell copy commands. So we can see here probably oh, actually what I was doing here is that the checkpoints are saved directly into Google Drive. So I could go here, I could all right, let's open a terminal. So I'm clicking down here and we open a terminal full screen. So let me see if I can do, so Python version. All right, so we can do Python out. So Python, we can run this import from Colab and we mount the drive, and I need to go into a different browser to this URL in order to paste an authorization code. Okay. All right, so I'm not sure if this is something I have to hide, but I'll just paste it here. Okay. So I've mounted the drive. Let me just scroll. All right, so we're here and I don't know if I can clear here. Okay. So I'm here at the bottom of the screen. So we have a terminal. What is this? Okay. And what I can do in here is that I can now ls on content drive. Okay. ls content drive. So if we add this bank, it runs this command outside on the terminal. Maybe not. Okay, let's see. ls. Okay, so I'm gonna exit the Python runtime, and now we can just clear the screen. So what I'm gonna do is content drive. All right, so inside of my drive, I have a bunch of stuff, and we have the style gun directory. All right, we have a bunch of models there. So I can directly go and say, okay, we're gonna make the content dot drive dash my drive dash live. All right, and inside of that directory, because we could list it, there's nothing there, and we can save files to there. So we could say from here, we could say content drive my drive live, and then file.txt. And I think we could even edit it if Nano is installed here. Yeah, not installed. All right, so what I'm gonna do, I'm gonna open drive.google.com. We're gonna go to this folder and I'm gonna show you the contents. So this is live. All right, and inside of live, you can already see this file.txt. It's empty, there's nothing there. I guess I could edit it, maybe. Some content here. I save, and in our other window, we just do cat, which is to print the contents of a file, and nothing's there. So let me see if I can ensure. Oh, file. File. All right. Anyhow, this is a folder we can interact with already. So we're gonna leave that here. Getting too many things open. And all right. So yeah, I think we don't have anything else important that we need to do here. I'm gonna close. We can open always if we forget something. All right, so let's do a bit of housekeeping. And yeah, hello, Major Mystery. Happy Thanksgiving to you as well. Thanks for passing by. And let me see one thing. All right, and now we're going to clear this. Let's see how our notebook is doing. If it's already trained. Okay, so we're training here and we're up to step 300. So this will finish really soon. So we have our experiments, we have our current experiment, we have our checkpoints, and we have these files here. So we could copy this over. So we could go into our terminal and say, okay, so so I can copy the path of this. So basically just right click, copy path, and I can, let me see if we can interact with the terminal. All right, echo test. All right, so we have this file, and as I said before, let's make this a bit clearer. So I can do, how can I make this bigger for you to see? Right, so I could do copy this, and now I can say to content, drive, my drive, live. We might not want to put it just there, but okay, we'll put it there. So that's copying. You see it takes some time because it's 1 gig, and it will probably take a bit to show up here, but it will show up here, I think. Okay, and you know that what that does is that last week we saw I was downloading a file, and from Google Colab it takes ages. So downloading them from here is a lot faster. All right, so we've copied to the proper directory. We can check by listing that directory that the file is there, iteration 300, and indeed it's here. So we can now copy that from a different notebook, and we can also infer. All right, so predict. And yeah, so I have this other notebook here. I'm gonna see if we can, too many sessions. All right, so we won't do it all at the same time. All right, so we have this notebook in here, and this is almost done, but we don't really care about this training because it's we already did this and it's a model we don't care that much about. So what can we do? Because this might take some time. I didn't save the latest model from last week. They might provide pre-trained models, right? So let's take a look at that, if they provide pre-trained models. And if you were not here last week, the logs images in here, the test images, we actually can see in Epoch 400 what this is producing, right? So this is the output. You don't really see anything in there that is too good. Okay, so let's take a look at why this is complaining. So view resources, manage sessions. I just have one session. I don't understand why they don't let me have more than one session, but that's what it is. All right, so we'll wait until step 500, and that's finished training already. Okay, and I think we only have iteration 400. Okay, so I'm gonna close this. So I'm just gonna I'm gonna copy over the last checkpoint. At least we'll have a bit more training, and we'll go here. Okay, so we'll copy 400, and we'll have that in our drive. Okay, so we're gonna go and get this code. So this Colab mounting code, because now I'm gonna kill the other session. So I'm gonna kill the session on this first notebook, and now we can connect here and request a runtime. On the meanwhile, I'm gonna check for the pre-trained models. So pre-trained, the notebook will download the pre-trained models. Pre-trained models. Sketch to image. pSp trained with the celeb AHQ dataset for image synthesis from sketches. All right, so here we have models that we can use to predict, and they actually have detailed code here that we can use to use the different models, right? They have methods in order to download define interface parameters, and these are the transforms that they define. And load pre-trained model, visualize input, align image, which is a super important step. So aligning the face to the frame. Celebs sketch to face and celeb sec to face don't run alignment. Oops. So it's not just passing an image through the model. We also have to have this concept of transforms, right? So you get the model path, the image path for the input that you're going to use, and the transform, right? So for example, if we go to notebooks, images, these are the three different inputs, right? So this is a sketch, this is a mask, which is a segmentation mask. You cannot see the colors, but it's actually, yeah, different shades of black. And then the input image, which is the actual colored image. It basically says just resize to 256, bring into as a tensor, and then normalize. And most of these are like that. We just don't normalize for sketch. and in mask we bring into a one hot vector, so we format as a one hot vector. And for celeb super resolution, it does some other things after resize. And the same for the Tunify. So I guess for our model, we could instead of download, we could FFH go encode. I guess we have a pSp FFHQ encode model, and we could put here iteration 400, right? All right, let's go step by step. Let's clear all outputs. And we would just want FFHQ encode. Okay, so we have a high RAM runtime. Okay, so let's clone. Let's do all of this here. Okay, so we are gonna download command. Okay, so let's do it with the default before we change anything in this notebook. And then visualize the result. All right, so this is gonna run the inference. After downloading, we'll run the inference. So this is downloading the model, which is 1 gig, 0.12 as the one we have. So we're gonna load the model. From checkpoint, so we can provide our own checkpoint. And then we'll do all of this to basically frontalize the image. Well, not frontalize the image, but align the image and be able to do so the model does its thing. All right, so this is the input image and this is the output. It looks really similar to me, but you know, I don't know this person, so it's really hard to know. So the first thing we could do is grab a random image. So we can go here into notebooks, images, and we can put a different image. So let's see if there's anything here. Well, let's use this one. Oh, no. Yeah, let me look for a photo. All right, and I'm gonna upload a photo here and put into images. Okay. And we're gonna rename to input Nono hat. And if that's there, so we have that file name, and we can set our input image experiment type, and we can manually define our experiment type here to be, so we're gonna do FFA HQ encode live, so cost live custom. Live custom. All right, so we'll paste this in our configuration. So what we're gonna do is we're gonna copy this one and we're gonna leave it below here. And this is gonna be live custom, and we're gonna have this, so images, that one. So for now, we'll use the same model that we've downloaded, and we'll use this new input image. So we'll run all of the cells that we needed to run to perform the inference, and then visualize the result. All right, again, well, shape reference before assignment. Let's see. Okay, let's try again. Okay, so let's actually download this image to see its size and properties. Put it here. So this is 1024 by 1024, and this one is smaller. Let me try to do something here. So let me look for another picture. Okay, let's try this one. Can I do this? Not exactly what I wanted. Okay, so we're getting a bit of a problem here with the formatting of the input images. Not sure why. Well, let's try with the same image we had before. Okay, so let's just put here how to, and I'm going to convert this into PNG. Okay, so now that turned, and I'm gonna try to do that again. Right, now it seems like it, and it's 960, so we're going to simply resize to that. All right, format it, and let's upload it once again. Images. Let's actually delete them. Okay, so let's put this here and images. Okay, had to. We're gonna run everything again. Okay, keep going. Keep going. All right. If it fails, I'm not sure what it is. Might be the channels or something. Yes, shape reference before assignment. Now it's rotated to the left. All right, so we're not gonna do alignment. We're just gonna continue. Input image. Right, let's try this. Image path. Shape reference before assignment. Let's take a look at this original image. Okay, so I'm gonna quickly open Photoshop and I'm gonna rotate the image. Okay. And okay. Okay. So I've exported this image with Photoshop, and I'm gonna upload again. Let's use the same name. All right, so we now see the original image here. We get the alignment model. We remove this that we don't need, and let's see if this fails again. Okay, align image has shape, blah blah blah. Okay. All right, so now this has, you see that the image is like this, but it's cropped the image to how StyleGAN images are framed usually. So I'm going to run this and we'll now visualize the result. Whoa, okay, that doesn't look great. Cool, so that's coming out of StyleGAN, right? So this is an image that is generated by the model, and this is the input image. So let's save that and put it on, this is 51, so we'll save this folder later. And I guess we can put this inside that folder as well. Okay, so to keep going, now that we have this working, this is probably not the best image, but what we can do is now here say this is going to be iteration 400, which is a model that doesn't exist yet, but we're going to copy over, so we have it here. Yeah, I'm glad that you like it. So this is basically a this is finding this image inside of StyleGAN pre-trained model, which is this. So I guess we could input other images. And now what I'm going to do, as I was saying, I'm going to do this. So I'm going to do start a Python session and say from Google .colab import drive. And now we're going to do drive mount content drive, and that's gonna mount my Google Drive into this drive here. We'll have to get another authorization code, which I'm gonna do here on the side. And once we mount the drive, we can continue with our Python session. And again, we can say, okay, in my drive live, we have these two models, and we can actually copy iteration 400 into content Pixel2Style2Pixel and notebooks. No, not notebooks. It was, let me see, pre-trained models. So yeah, we just need pixel type and pre-trained models. All right, and now if we list the pre-trained models that we have the one that we downloaded and this one. And bear with me, this is gonna be a really bad output. It's not gonna be like awesome or anything, but if I do this right now, we're setting that our model to be used is this one, the image path is this, and below here we say that we're going to use that experiment, and from now on we're just going to repeat what we had above, and we're going to visualize the output. And now the output is going to be super bad. It's just going to look like the original style gun image, one of those. I think, I don't think this is going to be extremely good, because this model has only trained for 400 epochs with really bad images, and the training set and the test set were the same images as well. Okay, cool. I don't know what that means, but yeah, so this is the other image that has been generated, right? So this is let's see, so 01 style gun Facebook config F, and this is iteration 400 images trained on 400 blah blah blah. Okay, so this was intended to go here. All right, so yeah, two images, different images. They don't have anything to do with the other, and in some way this makes sense, because they don't okay, so a fun one could be to run this with the Tunify model. Let's do that now. So instead of well, I mean, to use this as it's meant to be used, I guess we could do this. We could add our parameter here, and now we can choose here from our model or the others. So we're going to use Tunify, and yeah, so run. Yeah, Tunify, you're going to see now. And yeah, and to make sure that the thing at the top works properly, we're going to comment this out. And yeah, let's go fast. Let's run all of the cells to get the result. Oh, here he goes. Where is it? Yeah, we probably don't need to download this anymore, right? Because we've downloaded it many times. So, okay. Oh, it got the original image back. So this is what Tunify does. But I want to show it with my own image. Let's see, so input Nono had to. Okay. So Tunify makes it look like cartoons. Ha, well, I mean, I guess not really, right? I mean, you judge, but it doesn't look like me that much, right? Okay, so let's see. So what we can do instead of changing the experiments one by one is that we could, so let's inspect the experiment args, and so I guess we could do this and simply say, okay, the image path and we set the image here. So we could say notebooks, images, test.jpg. Right, and that changes that. So let's say Nono profile, which is not there yet, but we're gonna copy it right now. So let me look for that for a second. Okay, let's see if this one lets me upload. I don't understand why it doesn't. Can I drag and drop? Upload this image, and it's uploading. Okay. All right, so let's see. So this we need to rename as so Nono profile. That's what I said. And yeah, so Nono profile. I don't know if we'll have a problem here with the alignment function again, because I haven't done anything to it, but it's exported from Photoshop, so there might not be a problem. Yeah, no problem. Okay, yeah, it looks like these images seem really similar, right? Maybe it is that's my tunified version. This one does look a lot different, so maybe that's my tunified version. Maybe. Yeah, I don't know. I mean, it's fun, definitely fun. Let me see if there's anything else we can try here. Not that I have right now. Okay, so the interesting part here to me is we've used the model that I mean, if I just for the last test for now with this one, right, just playing out, we can now run this again with this is with the model that I trained that is not really fully trained. It's just like this, and we'll see a really similar input, I guess. Like maybe just the skin tone or something might change, but it's gonna be really similar. So let's see where this is at. Did something fail? Model paths. Okay, so yeah, our model doesn't really exist, so it doesn't really matter. So we just run from here. Yeah, so slightly different, but almost the same. So we can, I guess we can put this here. Yeah, it doesn't change a lot. Okay, so we could, let me see, maybe profile. Okay, so I'm just saving these things here to have a recap of what we've done today. And okay, so that was fun. So how do we now, because we've used, let me see, so from here we trained a bit. Actually we trained for 400 steps, and we copied the model to notebook, to Google Drive. We downloaded it from the inference notebook, and then we predicted with it. We predicted not only with this model that we've trained, but also with Tunify and other models. And now the challenge would be, so this is sort of like predicting, but now is how do we train our own model? We need to prepare it and train it, right? So I guess, okay, so I guess if I go in here, I've renamed this. So all right, so we can continue here. Okay, so let's take a look. So we have the pre-trained models. We've already seen that the inference notebook downloads it automatically. And here we have two models. These are not super helpful. I'm going to remove to not take up space. And here we have the training notebook. So what do we have to provide in order to train, right? Because what I see, so let's close this session from the prediction. Yeah, so instead of inference, to make it a bit clearer, I'm going to rename this with predict, because you train, save the model, and then load it, and then predict. And here, if we go back to, let me go back a bit and look for some slides. So I think last live stream we actually, yeah, we didn't copy this over today, right? So let me copy this into today's slides in here. So all right, so let's take a quick look. So Ricardo helped us troubleshoot the problem that we initially had with, let me take a look here, the problem that we initially had with the RAM problem. And this actually didn't solve it, but it gave me some pointers that it was about memory. And we reduced the batch size and the cores, I think. I don't remember what it was. Let me check. We reduced the so let's reset here. Okay, so we actually reduced here the workers. So there's like these test workers, the batch size, workers batch size, test batch size, and test workers. And that way we can train, right? We solve the things to this pointer. These are some things that I had shown before, which we're gonna skip today. And there were some notes here on how to train with custom trainers. Similarly, for generating images from sketches, please specify label nc equals 1 and input nc equal 1. Specify label nc0. Identify identity similarity losses. Okay, so sketch simplification. One thing that I'm missing from this repository really are the datasets. They mention Here we wish to generate photorealistic from sketches in style mixing here and support multimodal. The dataset that we provided here. So if I can bring it up here. So let's temporarily copy it to the desktop so we can all see it. So this dataset, right? It only has face images. It doesn't really have the heck. It doesn't really have anything. It doesn't really have a mapping. So what I was saying is that this is like 100 FFHQ. So this one is really good. Multimodal single person, multimodal. pSp framework is based on Nono encoder. Okay. So I do have a pre-trained StyleGAN models. So let me take a look here quickly if I can find the StyleGAN folder on my computer, on my Google Drive. Okay, so I have these models. This is a PKL, so this is not a PT. So I guess this is slightly different to how these are being saved. Okay, so I guess the pointer is 1 second. Okay, so let's see. So they're taking the pre-trained StyleGAN models taken from Rosinality. Okay. So these guys have a different code, and pre-trained checkpoints. Let me see what format they have, like in case that they use PKL. So they use PT. Okay, let's see, convert Stallion to checkpoint from PKL to PT. Oh, no, P5 PT. All right. Uh-huh. Right. That ad wasn't intended. Okay.
So with some of the tools that we use to manipulate our StyleGAN models, we're going to need to convert our pickle file, which is a TensorFlow file, to a .pt file, which is what we're going to use for some of the PyTorch.
Right. That's really good. Okay. So let's open this in Colab. Let's close the YouTube video because it seems like it's slowing down the machine a lot. So right now we don't need the predict notebook, even though I'm gonna add it to the live stream video already, so I don't forget. You can have access to them. And that reminds me that I need to that I need to make these notebooks public so you can actually access them with the link. All right, so let me do that quickly. So we have the predict notebook. All right, so okay, let's just put here predict notebook and training notebook. And is this one share? All right, done. Okay, so those are now in there. You can access with those links, and let's read that notebook that we have here. So let's actually clone it, save a copy in Drive. And let's go through this so we understand a bit more. All right, so this is gonna be this is StyleGAN2 PKL to PT dot PKL to dot PT. Okay, and this is live 51. All right, so let's actually cite here adapted from artificial intelligence YouTube channel. From the okay, so I guess that's their video. Okay, so they download both repos. You can upload it directly to Colab or use Google Down if you have the file on Google Drive. Okay, so we say where the file is, and okay. Okay, so first of all, let's try to, okay, so we'll close these ones, manage sessions, and yep, so terminate that. All right, so in here, we're gonna open a Python session from Google Colab import drive. I don't know if this is working. Yeah, I'm not too sure why we need the all right. Okay, so Python from Google Colab import drive mount content drive, and boom, another code that we need. So we're gonna move this into here. I get my code, put this here, and then exit and clear. All right, so content drive, so maybe let's just directly copy. So drive, my drive, style gun. Now we have a few options. So models. Let's take a look here at the sketches model. Style gun, sketches models. What is in here? $130. Okay. Okay, so we actually, before in here, I took a look at the style gun folder, and we do have this model. Yeah, let's just use this one. Okay, so we'll just copy that one into content. Okay, so let's list content. So that's being copied from Google Drive into this notebook, and we already have it there. And now we go back to the terminal. So let's see what we have to customize in here. Okay, just the name of this. So let's just copy the name of this. Yeah, let's try to run all. And for reuse. Okay, so okay, so this is downloading this downloads that file. So right now we're converting the file. I guess we don't really need this. Okay, and we're converting the PKL file to PT. So this is a notebook that was made for us, which is pretty cool. Let's see how long this takes. Okay, so we have those instructions. This seems to be working. Right, I'm gonna let this run for a second. We'll take a break. All right. I didn't expect this to to work at the first try. Even though, okay, so it might have worked even though we have a warning here. So it says convolution graphics not supported. Okay, so just a warning, and we have our PT file here and our PNG. Okay, this is probably too big. Nice. So this is working. Well, I'm unsure why this is empty, but this is definitely working. And I guess that top and bottom might be inference from the TensorFlow, so the PKL and the PT models. I'm not sure. That's pretty cool. All right, so we have converted our model. So now I can go to the terminal and I can copy that network snapshot PT to content drive my drive StyleGAN models, and I'll have them both one by one, side by side. Okay, let's see how it changes in size, because even though I'm gonna finish soon, we might have time to do a bit of training. Let me go. So we had that training notebook is here. So we need to do this here. So copy to drive, then download from training notebook, from conversion notebook. Yeah, okay, so our guideline here now is that we have that model that's going to show up here, right? The PT file, and it's a lot smaller actually, and it generates the same output. And now from this one, that is our training notebook, so we're connecting to a runtime, and what we have to do here is that we're gonna say, okay, copy content drive my drive models, and we want to copy this one into content Pixel2Style2Pixel, and pre-train models, and pre-train models. All right, let's run these two blocks because we're gonna have to mount again. All right, so we're gonna go here. Okay, so I'll put my authorization code in there. All right, let's try this. Let's content drive my drive. Okay, yeah, so yeah. All right, so I guess we'll have to put here StyleGAN. Okay. All right, so we cannot copy because we still haven't cloned the. All right, so we're gonna move this below. All right, so we're gonna run. Okay, so I'll run this cell here. I'll run the Ninja one and I'll clone the repo. And then we're just gonna test that this works. Okay. And we're gonna make the directory pre-train models. That doesn't exist, right? All right, so now here we should see pre-trained models, and I have my network snapshot. So what I'm gonna do is I'm going to continue running cells, and here we have StyleGAN FFHQ, but we want to change that. So maybe, maybe I'm gonna do that by hand right now. FFHQ encode, and that's leading to FFHQ encode, StyleGAN FFHQ. StyleGAN weights. All right, let's take a look at that. Okay, scripts, train.py, and okay, let's go to train options. StyleGAN weights. All right, so we can actually provide directly. Cool. Okay, so here we'll do here StyleGAN weights equals pre-trained models, and then this name, and just to make sure we don't need to download this. Okay, so we've run up to this, so we'll continue running, and all right, so we'll train, I guess we'll train for a bit, but I'm gonna, yeah, let's actually, so if this has run, so everything's here, I want to make sure that we leave this up, so yeah, okay. Okay, so okay. It seems we might need to do restart runtime. Let's see, we might not have to mount the drive again. All right, so this is gonna train now, and hopefully we'll get our first custom Pixel2Style2Pixel model. And note that right now we're using the same images for training and testing, which we shouldn't do, but for now it's okay. We're just testing to make sure that these things work. Okay, again, this is gonna take a bit, so screen share is no longer active. Let me restart. So let me start this again. Let's see where we were. Okay, so where we were before. Great. So let's do a recap. Let's see how this is going. Type StyleGAN weights pre-train model. All right, so that is here. All right, let's try to see here. So the let's do a quick recap here. What have we done, right? We've created a notebook that trains, and this trains pSp. And we have another notebook that we didn't do it, we just used it, that predicts. So this train notebook has to, we basically generate PT files and upload them to the cloud. And the predict one downloads PT files and then predicts images. But we are trying to get our, we got from the internet another model that it's a converter that basically does PKL to PT. So this is also pSp. And now we're trying to adapt this one so we get our own custom PT, and then we also train pSp, but with a custom model. How is it custom? Because this contains a StyleGAN model or a StyleGAN PT file that that Nono trained on sketches. And I think that happened on Nono.MA live 24 and 25, and let me check. Let's see if this worked. All right, seems like something's working there. Let's take a look where this is. All right. StyleGAN. Yeah, I think these ones are the ones I need to make sure, but it would be good if we name them, because that way
new group of expansions in this particular application. I can put here, for example, I don't know, let's say a website. So we want to make expansions for
So 23, 24, and 25, I think, are the videos. All right, so this should be training. So this is already trained for 200 steps, and we should have models here. So inside of our experiments, we have checkpoints. So we have these models, and we have images. So let's go to the test images. It says faces, but ignore that. These should be faces as an input, but the output is gonna hopefully look as a sketch. So nice. Okay, so this is really weird, but this is what this face is outputting in here, and this is what this one is outputting. Why with faces, I'm not sure, but that's what we have. So let's open a few more. Yeah, right now, as we saw with previous models, almost everything is gonna look the same. So we're not gonna see a lot of variation, or no variation, because I don't see any variation at all. Yeah, I mean, there might be some correlation to this, but it's really hard for us to even try to understand why these images are showing up this way. Okay, so let me see, how far are we? Okay, I'm gonna let this run for a bit, and we'll take a look at the results. All right, so let's put some text here. All right, we'll be back in a bit. I'm just gonna wait for this to train, and then we'll wrap up. See the results and wrap up. Okay. All right, I'm back. I will invite anyone who's online right now to type on the chat and tell us where you're connecting from, maybe your name or who you are, and how you found us, and what you're looking to learn from this live stream or why you joined. So here we have, let me save this image. So before we saw this image, right? Let me unzoom here. Okay. So we saw this image here before, and what this image is pSp validating how well it's performing. This, or I mean, visually we can see it. It doesn't really have a metric, I think, here that we can see. We have this input image. This is the target. So this is an image that we're inputting, and this is the target from StyleGAN, I think, or no, actually, this is because our test set has this as input and this as output. We're using the same data set as train and test, right? So this shouldn't really be, because the ground truth is exactly the same as the input image, right? In here, we were getting an image that doesn't look anything like this. So this is an experiment, and I don't know if this is going to look as bad as this or if it's going to work better, but we've been training for more than 1,000 steps now. So I'm going to move, and we were talking before here about what we were doing. So let me see. Let's leave this aside for a bit, and let's actually take a look at the actual images that have been generated by the latest iterations of this training job. So we're up to 1050 training steps right now. So I'm gonna go in here. As you can see, we have the PT checkpoints of pSp, so we could save those in case that they yield any good results. And in here we have those test validation. I'm kind of nervous and scared to see if this is gonna be any good, but let's take a look. So this is our input image, and this is another input image, and we're gonna see on the right, on the far right, whether this is giving us something meaningful. All right. Oh, so yeah, okay. So I guess it's learning a mapping, but nothing really that that we can relate to, right? Like something that it's this really weird thing that I didn't even know was on the StyleGAN latent space before. But yeah, I don't know. Let's keep taking a look. I mean, this is a weird experiment because I'm trying to input faces into a dataset to get things that look like sketches. So it's a bit weird, probably, whatever this is understanding, but also a suggestive way to create images with StyleGAN. That's actually nice. It's a bit weird, but it's nice. All right, so yeah, I guess we should have a way to directly copy all of the images here into a folder in Google Drive to be able to keep these experiments and be able to take a look later. Okay. Yeah, but what this means is that the model works. It's working its way through. All right, so let's do one thing. Let's actually download all of these images to keep them. I'm not gonna copy them into Google Drive right now. So I'll open a terminal. So I think do we have zip here? Yes, okay. So we're gonna go to Pixel2Style2Pixel. We're gonna go to experiments and this experiment, and then we have logs and we have images test. All right, so inside of here we have faces, and I'm gonna go into faces and I'm gonna zip that directory. And I think, yeah, we have our faces.zip. So now I'm gonna copy faces.zip into content, drive, my drive, style. So 1 second, my drive, stylegan, live. Yeah, we'll just put it there. So C command, so we could put CP here. All right. Okay, so we just have a typo there. Okay, so cannot create regular file live, not a directory. Okay, so many errors now, it's late. So stylegan live. Okay, so that's being copied over, and I don't think I have the drive open, so I'm gonna open it again. And okay, so here I have the drive folder, and as you can see, faces is here, so I'm gonna download it. This is, yeah, okay. Cool. So now we have all of the images in our computer and we can go through them. All right, let's enjoy this a bit more. So we do have, for instance, this, and okay, so this is where it starts, I think, right? So if we go, okay, so this is generating some images, and this is arguably learning to do that mapping, right? And I don't know what we'll find. I don't know where we will get. It seems like it's trying really hard to learn the mapping, but it's having a really hard time. Well, this tells me that we should probably give it some more time to see what really happens there, and if we get something that actually looks good. I'm not too hopeful. I think the domains are super different and not something that we might find something useful, but it's worth waiting just to see if we can get something out of it. Again, I'm gonna delete that iteration file because we have iteration 900 from the same model. And yeah, these are inputs that you would get from the actual model, as it's meant to be used, supposedly. But I'm surprised of what the the Pixel2Style2Pixel model is doing to these images, because it's trying to go, like, trying to find, it's actually finding things in the stylegan model that are really weird. Starting to see mouths. Okay. Okay, I guess I'll let it continue. I'll let it go. So okay, maybe all right. So actually one thing that is happening is that we're training a lot slower because we're evaluating at each step. So, you know, we are making the model a lot slower. In that way. Okay, so I'm gonna take another break just to continue with this later. Okay, there is one thing I'm gonna do while this trains is I'm gonna try to make a cell here that copies the latest iteration, which would be, I guess, Style2Pixel experiments. Checkpoints, best model.pt into content, drive, my drive, live, and would also go into the logs, images, test faces, would zip that directory, and then it would copy into the same directory. So we can actually try that this works already in the terminal, just to make sure that we're not going to mistakenly not copy that. All right, so okay, so we'll copy this into here. So best model. will and right, so this worked. And after that, we gotta copy to, okay, let's run one by one. This one worked, right? So we have best model there. Okay. Right, so that one worked, and the second one worked. So I guess now we can do touch. Well, let's clear. So we want to let's actually try. Let's try them together. So clear. Right, so let's try to do that. And let's see, so we're in 1800 already. Well, something's happening there. I don't know what this means, but something's happening. I guess then we can actually get a set of sketches, and this should work. Okay, so I guess after these trains we can run this cell and we'll have the best model. And okay, yeah, so because this is gonna take a while, I'm gonna call it a day, and I'll share the results next week. Thanks for everyone who's connected today. In case that you're watching still or you watch this offline, I'll invite you to like this video to support the channel and to subscribe if you want to get notified when I go live next or when I upload new videos. Feel free to reach out through the video comments or on the website or on the podcast, wherever you want, on Twitter at Nono.MA. I'll love to hear from you. Bye everyone. Thanks so much for being there. You can also join the community. There is an invite at Nono.MA Discord. And yeah, thanks so much. Thanks for watching, and I'll see you next time. It was Nono Martinez Alonso here. And yeah, any comment that encourages what I'm doing here or supports the channel is awesome. You can also support by clicking on the affiliate links on the description or by sharing these videos. Thanks. I hope you got something out of it. Bye.